So let's take a look at agentic computing. So the first thing is, what is an agent? Well, an agent is basically an LLM model plus instructions plus tools, but also memory, for example, and we call this the runtime. The agent is running in some kind of container, perhaps on your own machine, but also up in the cloud. And we can store data in memory. So we'll see that we need to manage the context window because, as we saw last time, the LLM can't remember anything. So this is the basis of our agent, that we're going to give it tools, and it's going to tell the LLM, hey, I have these tools. If you want to run them, just tell me and I'll run the tool for you and pass the result back to you, the LLM. So we're going to give the power to run tools to the LLM. Okay, so we looked at the way that the prompt builds up. So here, the first thing the agent does is say to the LLM, okay, I've got tools and I'd like you to answer this question running one or more of these tools. So the LLM may ask, okay, run this tool. The tool result is given back to the LLM, and then the final result is passed back to the agent. Now, we can store all of these messages in the context window in memory. So here I'm showing the agent's memory, that we've got the prompts in it and we've got the tools, and now all of this conversation can be put into the context window and passed to the LLM along with a prompt that will ask the LLM to do something for us. So we'll see that handling this memory is one of the things that we need to take care of. We saw as well that we have in-context learning, where we can pass data into the context window and we can choose the data so that it will answer the query, that it has the information that the LLM might need to be able to answer the query. So that's a RAG system. And typically here we'd give our agent RAG memory, so that would be for documents that it can use. We'd probably give it web search capabilities, and we'd allow it to run code. Remember, the LLM is not very good at mathematics. So typically that will be a basic agent, if you like. It won't necessarily have all those tools, but it can do. Now, when we talk about RAG, basically we need to execute several functions that we might need to put a document into the RAG system. We might need to embed that document. We might need to query the RAG system. So these would all be functions associated with that RAG system. And it's the functions that the LLM calls. So we need to be careful about the naming of these functions, so the LLM is able to determine exactly which function it's calling. And we'll see this is potentially why we're going to need more than one agent. We'd like to separate concerns, that we'd like an agent to have a clear purpose that the LLM can understand so that it can just run it, and that we don't overload the agent with lots and lots of tools that may get confused by the LLM. So now we have a number of tools, and here I'm showing that we've got 5, and these are functions that can be fired. Now, Anthropic decided that it would be good actually to have these served up by some kind of server. And the advantage will be, we'll see later, is that this server may exist across the web somewhere. what we'll see in a corporation is that it will spin up standardized MCP servers. Now, STDIO is standard input and output. Now, this server must be run in the same environment as the agent, so the same container. If I'm up in the cloud, it'll be a container. If it's on your own machine, it'll be running on your own machine here. So we'll come back and look in more detail at how these MCP servers can be constructed and how they can be run. Now, let's take a look at a multi-agent system. Now, the idea with this is that we won't give all the tools to all the agents. We'll have specialized agents. So here we've got a triage agent. Its job is to look at the prompt and understand which of the agents, the planner, the search, or the writer, that prompt should be passed to. And then once one of these agents is finished, that it may return the result back to the triage agent. Now we'll see that managing, again, the context window is very important, that perhaps not all these tools need everything that's been recorded in the context window. So this runtime memory is important, and if you code, you'll be using it a lot. So here we have these three agents, sub-agents, and this is a triage agent, so it's the kind of main agent that decides who should be doing what, and then we have various tools that these agents can access. So we'll come back and we'll talk in more detail about multi-agent systems and how we can program them. Here's an example of a multi-agent system, and here we've got two types of MCP tools. So MCP, as I said, was invented by Anthropic, and it stands for Model Context Protocol. There are two types of server. One is communicates over standard input and output, STDIO. The other is server-side event, SSE. And these servers run on a URL. So these servers can exist either within the same container or can run on a totally separate machine. And to access these, we'll need to develop a client over here that can talk to these servers. But there are standardized clients. So this would be a fairly complex system here with these serving up lots of functions. So here I'm just showing these little blue dots as being an individual function. And basically, it's these functions that are given to the LLM. The LLM doesn't see these MCP servers. Okay, so that's basically the tools and the building blocks of agentic computing. And we'll see that everyone recommends to keep it simple. That once we're putting the LLM in charge of making these calls out to various tools, it can get complicated quite quickly. So we'll talk a little bit more about what the best practices are for building agents. Okay, bye for now.